I wanted to welcome you on this session about SUSE AI. I wanted to tell that we are here in Czech Republic. You can contact us on our emails and phones. That's no issue. And I wanted to welcome Eric Lajoie, which is main guy for AI in EMEA region in SUSE. We would like to talk about SUSE AI and present it to you so you know there's a solution from us as well. If you can take over, Eric, thanks.
Yeah, thanks, Lucas. So there's chat in here. So if anyone has any questions, feel free to drop a question in the chat. We will be finding a way to attach these slides to the recording later. So if you have anything you want to grab, you're welcome to screen grab it, or you can get it from us on the shared video later. What I'll cover with you today is, as Lucas said, what SUSE is doing in the AI space. I'll cover what we're doing on our platform side. I'll cover what we're doing on our application side in the AI space, and where we're looking to go in the next fiscal year or calendar year for product enhancements. I'll also be demoing some of the pieces we have today on the truck, for example. We have a digital assistant that works out of the box that can be highly customized for any kind of customer use case. And we'll also go over MLOps frameworks, which are important for a lot of the large scale customers trying to do machine learning or generative AI and training and model serving, for example. So with that, let's get started. And if I talk too fast, feel free to say, slow it down. We have the time. Share my screen here. Okay,
Perfect,
so
Eric.
I'm gonna first, yep, all good, Lucas? We'll go, okay,
Yeah, all good, all good.
perfect. So what we have here from the product stack, I wanna just show where we have integrations with other partners. We have a large partner ecosystem. I'll cover the ones we have in the AI space in a short while. But here it's important to see that SUSE is an open source company and everything we do is done from upstream code. And we also have partners who fit into our solutions based on the need. So we actually have some other Linux distributions we work with on the bottom operation system layer, but we also have stuff in the Kubernetes networking layer. And these are all very important for AI customers because on the networking side, you'll have things like Istio, you'll have different CNIs based on tenant separation, things like Metal LB. These are all things that are used in the AI space for specific use cases. And we support them all. And we have a lot of partners doing stuff in this space. On the storage side, it's highly important to have the right performance storage and the network to go along with that. So we have integrations with lots of partners on the storage side. I can mention a few. I don't want to make the other ones I forget to mention feel bad, but you can always reach out and look what we have in our partner ecosystem there. On the GitOps side, you can see we have third-party integration there. That's typically where we work with some of our MLOps partners that have their own MLOps, which is just an expansion on GitOps or DevOps into the ML space. So that's quite a good thing to have in your open source platform. Now, when I say platform, I'm talking about the software that's either sitting on a public cloud or software that's sitting on your servers. So in the AI space, you may have a DGX server from NVIDIA or an AMD-based GPU or maybe even Huawei GPUs or others. SUSE is a thin green line in that type of a deployment. You'd have SUSE Linux on the server. You'd have our Kubernetes running on top of that Linux. You might use our SUSE virtualization if you want to do multi-tenancy across virtualized environments, which I'll show you shortly, and Rancher Prime. So Rancher is a way of managing all of your Kubernetes environments in AI and IT together. So it allows you to lifecycle the Kubernetes platforms, and do the same for the workloads and the models and the other things that you run on top of the hypervisor being KubeVirt or the Kubernetes being containers. We have SUSE Security. This is very similar to industry leaders like Palo Alto Twistlock and Sysdig. It's a software firewall capability plus policy. So on the policy side, you can have things like if a container tries to start an SSH process to either kill it off or inform operations or security, If it sees a network policy go outside a standard network policy path, like trying to reach out to Hugging Face to inform on what kind of inference you're doing in a model that's got an agreement with Hugging Face to capture that. Um, some customers we use security to fence that off and block it in a non-air gapped environment. SUSE observability. This is our standard IT observability platform. Think Prometheus Grafana, but add in a time series database and the ability to time travel back in time to look at issues as if they're live, which is quite useful for teams that are managing the platform to be able to see these are the things that failed and in which order and what was the root cause. Now, on top of that, we have other things for doing, I mentioned air gap earlier. We have a private registry and multi-Linux manager and other things that are included in this stack from SUSE called SUSE AI Suite to help you manage air gapped and non-air gapped. We've extended this platform for AI. In our observability, we have basically a collection of apps I'll show you later that are built with something called open telemetry. Now, with open telemetry, you're able to see what the apps are doing and send traces and metrics from those apps. What that means on the AI side is that we can see if every user on this call is talking with OpenAI, when you send your question, hit enter, and you get an answer back, the process of sending that question and getting answer can be called inference. And with our observability, we can capture all the inference going on back and forth between the models, either on-prem in an on-prem environment, on GPUs or on CPU, or on a public cloud, if, for example, if you're using OpenAI. So we can capture all of that. And what we do is we count the number of tokens in the inference. We actually can assign pricing to those tokens. So you can use our AI extension for pricing out groups or users on how many tokens they use across a certain time period. And what we also have in there is integration with NVIDIA's basically GPU operator. It's called DCGM. It's just an acronym for the metrics and reporting on the GPUs from the GPU operator. So you can see things like how hot the GPUs are, how utilized they are, and how many watts they're pulling. So for example, if you have 8 GPUs given to one user, you can see that they're only using one, for example, and those 7 can be handed off to a different user or group. And typically I see customers use the observability extension to do billing and to do reporting and cross-charging. So seeing, where the heavy users are and, seeing where there's resources not being used and can be given to other people. Now, before I hop into the apps, I want to touch on where I'm seeing the most questions coming from people starting their AI journey. Now, there's a question first, let's say the customer has, in your case, if you're a customer, you have a business case that you have funding to buy this expensive new hardware, that you can get these GPUs in a certain amount of time. And then you have questions like multi-tenancy. Do I want to make one large cluster and give all my users access to this one pool? Typically, the answer is no. And then the question is namespace separation inside of Kubernetes good enough for the separation? Again, typically the answer is no, but that still works. I'll show you digital assistant later. You can do digital assistants across multiple namespaces in a cluster, and it could be like an HR one, an IT one, and so on. And Lucas, let me know if you see anything in chat because I'm not watching it right now.
Everything's
No?
okay.
Perfect. So that's where this middle and right option come up. So there's a difference, a very slight difference, but an important one, and also an expense, not expensive, but it costs more for one of these options. The middle option is typically multi-tenancy, meaning that you give every tenant their own virtualized Kubernetes cluster. And when you do that, you can then give one or more GPUs as PCI pass-through up to those tenants. And this works really well, does multi-tenancy. It's easy to operate, easy to lifecycle and maintain. And then your data scientists and people doing the AI work on top, they can do whatever they want with those GPUs in Kubernetes. You can even have a Linux VM running on top of there. It doesn't have to be Kubernetes. Sometimes I see, Jupyter Hub is the only requirement inside of a virtual machine, and that works in this middle scenario as well, on top of with SUSE software. The catch is that if you're spending 80,000 euro per GPU or 60,000 euro, and let's say there's 100 units of memory. I won't get into how many gig each card has, but let's say there's 100 units of memory on a card, and that's the resource most utilized by, let's say, LLMs. And you build this. Sorry, guys, I'm back. It looks like the connection broke and I didn't see the message that it broke. Lucas, are you there? Martina?
Well, it's working for me as well already. Hi, great. You connecting basically at the slide like 2 or 3, so we were not sure
Okay.
if you will come back. It's great.
Yeah, I'm gonna join on my phone, so if this disconnects again, I can see it in 2 places. Give me a second here. Apologies about that. I think it's the fact that I'm on a roaming on a 5G connection here. Um, okay, I will share again. And Lucas, I'll have my phone here, so ping me if you see any disruption,
Okay,
please.
okay, I
Okay,
will.
perfect. And where did it cut off, just so I can go back there?
That was the NVIDIA screen with bare metal virtualization, those 3 tabs.
Got it. Okay.
Yeah, I would say
Per-
this one.
Perfect. Okay. So did I talk about vGPU in the recording at that point?
Yeah.
Okay. So if there's any questions on the hardware side of things, please let us know in the chat and I'll take a look. But from this side, this is the multi-tenancy approach that we've covered before I disconnected. From our partner standpoint, we have multiple partners. We're working with Catonic and ClearML in the ML ops space, Altair and HPC, Avacia. They're interesting for their ability to oversubscribe GPUs. So they allow us to basically do gold and silver tier and to be able to oversubscribe GPUs. And then our AIM partners partner, they're working in the EU Commission on the AI Act. So we usually work with them with customers who are worried about making sure they're adhering to the policies of the AI Act in Europe, along with other local policies per country. Now, from a framework which I mentioned earlier, we have Kubeflow and MLflow, which are two tools used in the MLOps framework approach. We also have Jupyter, which is based inside of Kubeflow as Kubeflow notebooks, as well as a separate Jupyter Hub tooling. So for example, if you want to have your data scientists use just a Linux VM with a GPU in it to do whatever they're doing in the past, we can continue to do that with the SUSE stack by allowing Jupyter Hub and whatever other tools and libraries they need inside. And if it's a large scale customer who needs to have a common approach for all of their artificial intelligence teams and have it be reproducible and auditable and actually do quality assurance in what they're doing, these larger frameworks like Kubeflow and MLflow allow large companies to do that. So we'll take a look at that shortly today in the demo. Another thing is that we just released Universal Proxy. So this is basically something that we released 2 weeks ago, and this allows us to do something that's very kind of bleeding edge in the industry. So if you've looked at agentic workflows in the past, you'll see that, give me 1 second here. Just gonna make sure my phone doesn't turn off, Lucas, so I can see what you say. There we go. So basically, this was something that we got asked by the customers that if they were using MCP, they had a whole bunch of problems and issues using it. And what that means is that if you look at SUSE, for example, we have MCP enabled in SLES, we have it enabled in Multi-Linux Manager. And the way you can think of MCP, if you're not familiar with it, is if you're logged in as a root user into a Linux OS, you can do a lot of things like reboot a node or similar. And you can also get data on anything like, is the web server running in the Linux node? MCP exposes that through Common API framework. And when that's there, your agentic workflows can then talk directly to a Linux node and do things to it. Now, the customers that we've talked to say that they're really nervous about enabling MCP because they don't want anyone to be able to go unauthenticated into a node and do something. So sometimes the MCP endpoint does have TLS or it'll have encryption. Very, very rarely will you see role-based access control in the MCP endpoint today. So that's what we came up with this universal proxy as a way of doing role-based access control in front of the MCP endpoints. So if you have 1,000 Linux machines with MCP or a multi-Linux manager with MCP, on the right side, you could have like Open Web UI or your agentic agents running there, and they can come to this proxy. And based on what permissions that have been set up via OpenID and role-based access control or group mapping, they can either be allowed to reboot a node and see if the HTTP server is running, or if it's someone who's just doing operations at a junior level, they're only allowed to see if the HTTP server is running. So it's a way of limiting or restricting or enabling certain capabilities inside the MCP stack of each product. What we're doing over the next 6 months is we're working on something called virtual MCP. So if there's something in your network that doesn't support MCP and maybe never will, but it does have CLI or APIs to do things there, you can then do a virtual MCP where you build a plugin or have your plugin set to talk to that specific application. And then on the right, it's still MCP. So your agentic workflow doesn't need to have its own customization to talk to a non-MCP enabled device. You can use proxy to do that in a central way. Now, from use cases, what we have today is um, we have this digital assistant where it's Open Web UI as our user front end, OLAMA or VLLM for loading the models. This is usually OLAMA for 1 or 2 users and VLLM for larger, more distributed environments. Milvus and Open Search here are the vector databases. So if you're going to do RAG training, this is a good example where you might store your RAG trained data and then having a model use that data for its RAG trained data outputs. If you're going to work with SUSE in the AI space, just know that we have some predefined 2 and 4 week services packages. So we go in and we take people from our services team that have been delivering these AI projects that can come in and help local teams or local partners skill up if they haven't done so on these type of technology. And usually it just means you get a quicker time to market on this type of investment. Now, when you use SUSE AI, the suite that I showed earlier with the entire stack, what we have there is the core-based and socket-based approach. So if you're going to be running on bare metal, you're going to want the socket-based approach. And if you're going to be running on like a hypervisor, you're going to want the core-based approach. And let's see here. I'll share these slides. So these will hopefully be attached to the video, but we have some reference architectures you'll get in a later time. And also our roadmap. You can go through and see what we're going to be having over the next calendar year. Now, demo time. Any questions before we get into demo time? Just hop back here and check the chat.
I don't think
Looks like
there are any questions yet, but feel free to ask anything. Eric is the guy to target those two. This is a perfect one to have here.
yeah, and tough questions are good. Even if you're from a competitive partner, I welcome them. Cool. So let's take a look at some demo stuff here. I mentioned Rancher Prime. So I'm just logged into a few things from previously running through this content, but from within Rancher, if you wanted to start an AI project, this demo environment is probably a pretty good thing to take a look at. I've written a blog on how to build this, so I'm going to paste this in the chat if anyone wants to play around at a later time. And Lucas, we just make sure we get this the SUSE version of this plugged into the webinar when we're done. In there, this is a single node server, just happens to be a 32 core system with a single RTX 4090. And this is running one required application, which is the NVIDIA GPU operator. So this operator here installed the driver and exposes the GPU into Kubernetes. So at this point, you have an AI platform. You can run AI workloads and not have to worry about supportability and being able to run things outside of the fact that there are you need to align on the CUDA versions and stuff like that. But if you're working with NVIDIA technology, you'll be aware of the requirements of what operators should use and drivers and so on. Now, the first thing that you might want to try is what's in that blog is to open and install Milvus and OpenWebUI. So Milvus and OpenWebUI, the combination actually is 3 in total applications that provide you this type of experience. So what I have here is OpenWebUI, and OpenWebUI is the front end that talks to Ollama or VLLM and also does the inference. So if I go here and do a new chat, I can go in here. This is a 5.4 model, so you can of course go to Ollama and download any. And again, this doesn't have to be on a GPU, but you do get a lot better performance in terms of the speed of the output if you're running on a GPU. One of the caveats here is if you see this model here is a 14.7 billion parameter model. What that means, it's going to take out about 8.4 gig in size, but that's a little bit bigger on the GPU. Let's take a look at that. So I would say, what is the, what's a good question? What is the best food in, Lucas, what city are you in?
I'm in Czech Republic, Česká Lípa.
Okay, I can't spell that for the life of me.
I guess. Well, you
Okay.
can try Prague, I guess. It will be the best.
Okay. Yeah, let's do that. Okay, what's the best food in Prague? This is Microsoft's open source LLM, and according to it, #1 is this. And I don't know if I've ever had that.
That's actually crazy because not even Czech food, but okay, probably the most
Cinnamon flavored dough.
mentioned by travelers all around the world, I guess.
Yeah, because this is trained on the internet. Exactly.
Yeah.
So this model is now loaded in the GPU. And if you're going to be working with AI, you're going to want to get used to these type of commands. But I know for a webinar going command lines, probably a rare thing, but it's good. Okay, I'm back. Yeah.
Perfect.
Whew. Okay, it's official. Deutsche Telekom only lets your data connection last for a certain number of minutes, and it looks like it kills it and then restarts it. Okay, back to screen sharing here. So the NVIDIA tooling. So basically, I believe I lost you guys when we were starting to look at the CLI. So we just ran that and looked at the food on that. We can see from NVIDIA SMI, this tooling on CLI. I know we're going a little bit too deep on a webinar in CLI, but it's good you see this. And basically, you can see here I have a 24 gig U resource, and in there, Ollama, for example, which is I'm using for the inference, is using 10 gig of VRAM. That means that this chatbot with 14.7 billion parameters taking up 10 gig of my GPU. So I can actually run another model in tandem inside of this one GPU if it fits in the VRAM, if I want to have the same speed of output. With this SUSE software, you can easily go in and do things like RAG training. So you can create these knowledge buckets and in there upload documents that you want to have be used for RAG training. And then basically have a full digital assistant. And then there's even third-party integrations you can look at. So that's the digital assistant. Now from there, I want to just cover with you, we have this thing called AppCo, or application collection. And in there, it's apps.rancher.io. And there's a stack section. And in there, the SUSE AI stack exists. And what you have is you have this stuff I've shown you already a little bit today. We have Milvus, MLflow, Ollama, OpenWebUI. MCP operator, and pipelines from OpenWeb UI, PyTorch, and VLLM. The VLM we have here is tooled for NVIDIA. So if you're going to look at using VLM on AMD, for example, it might be good to use the AMD generated one. The same for AMD or for NVIDIA, they have their own VLM. It just depends on what you need. And for example, the stuff you see here in APCO is slightly different than what you'll pull from upstream, for example, in the sense that these applications are built on top of a SUSE base image. So that means that, like, for example, MLflow was updated 8 days ago. This MLflow may be a month or two old from its release, but all of the packages and libraries underneath that are built in the SUSE base image have been being patched to make them CVE free over time as CVEs are patched. Um, it also comes with an SBOM and other things. So if you're in the security field or if you're looking at secure pipelines and building applications securely, these are all things that SUSE provides as part of AppGo. So basically, it's a secure source for you to build your applications. If you're going to build your own digital assistant, it takes literally 40 minutes max to get everything up and running from a Linux operating system. If you go through that blog I shared in the chat, it's something pretty easy to walk through. Okay, now Kubeflow. Kubeflow is in there as well. A lot of all of our other kind of frenemies on the market are doing similar. Kubeflow is probably one of the most popular, but also the most complicated ML ops tooling that I've seen right now being used by customers. Again, to use this, the data scientists are probably, if you're not a data scientist on call, you probably know what this is. If you're not, just note that the people who use this, to use this versus using another tool affects what they're actually coding in their Jupyter notebooks or VS Code with their machine learning or generative AI, let's say coding that they're doing. So if they're going to do pipelines through Kubeflow, that's one approach. The other is we have something called MLflow that can be used in parallel or and or. Um, just give you a quick view on this one. So with MLflow, it has this concept of experiments and models and also prompt engineering, but this one is as well has a big impact on the data scientists and how they do their coding. So typically when I'm working with customers or partners and we're looking at, is it MLflow or Kubeflow or both or combo, it's usually having a quick discussion with the data science team if there is one, and if there isn't, and it's a kind of a SaaS offering that's trying like a GPU as a service, typically you want both of these and put them in your catalog, and you'll give one full install per tenant type of approach. Okay, so from there, also there's this concept of Kubeflow notebooks. So we have separate Jupyter Hub that can generate these notebooks, or notebook servers per tenant, but also having the notebooks in here, you can integrate them directly into Kubeflow pipelines. So if you're going to end up doing Kubeflow pipelines, you'll probably start generating these notebooks from within Kubeflow. So you have the concept of Jupyter Lab notebooks, VS Code, which is basically a web-based version of VS Code, and RStudio, the same. And in there, you can define CPU core, memory, GPUs, and so on for those users, depending on what the data scientists need. So this is like a GUI that your infrastructure team would use to generate the working environment for the data scientists. Another approach to this, if you want to go super simple, would to be having a Linux image that you start on top of your hypervisor with the Jupyter notebook running in the VM locally. That gets rid of the whole Kubernetes layer if the data scientists don't need it. But again, this comes back to how a company as a whole might decide to do their AI approach. Okay, Lucas, with there, I'll take a pause, see if we have any questions.
There's only one question. If you are able to use SUSE AI internally, or this internet only for the customers, I would
Yep.
say we should be able to use it internally as well.
Yeah, and internally, it might mean air gapped or internally in a company without having access. So the good thing about this is everything that I've shown you can be run on public cloud, it can be run on bare metal servers, and it can be run on a hypervisor. It can also be run air gapped. So you can actually put this in an air gapped environment and have a registry having all of this stuff stored in your environment. So you're going to have probably one node that has one leg on the internet to download all those resources and images. And then the other leg is facing your environment where it's going to serve up that as if it was coming from the internet. So all of the things we have air gapped. You can go on to SUSE.com. So if you search for like SUSE AI install, you can then go in and check our deployment guide, and we do have an air gapped deployment guide in here. So the documentation is quite good. The only reason I've written a blog is that if someone wants to just quickly try this out in an hour, the blog will allow you to achieve that. Did that answer the question? Okay, perfect.
think so. There's one a little bit more specific one.
Okay, yeah, that's a specific use case. So I can answer half of that. First, you need to choose which model you want to use for optical character recognition. So you're going to have a camera most likely, right? And it's going to be, so I've seen some customers do OCR in an edge node. And then there you have a machine learning model that's using something like YOLO V5 or something that's doing the optical recognition, doing the recognition and sending MQTT messages back to the central data center where a larger model is. So you do the recognition locally on edge and then centrally do something else. It depends on how the use case would be structured. Let me finish reading and see if you highlight that. Reliable existing tech. Okay, text, diagrams. So on-premise A inference without dependency on cloud. Yeah, okay. Model, vendor neutral approach. Yeah. So what I would recommend here is, if you want, you can reach out to Lucas and I, and we can tell you what partners we have in that space. But if you have a preferred partner that does the OCI, it's basically going to be a partner that makes a machine learning model that can do that can take video streams. So most of the OCR apps, they have a video stream they can get and then do the recognition and spit it out. In terms of the content and the diagrams, it's going to be on that ML. If you want to make your own machine learning, find the machine learning project out there that does this already, and then basically do your own training on it. So for example, if you want it to do the diagrams, find one that already does diagrams, and then start getting your data scientists to use it to train it on your own example diagrams and documents. Because maybe there's some diagram styles that it's not trained on, so it doesn't actually do a good job turning them into diagrams. And maybe the language, there might be not as good a training on the specific language you want to use for that. I would say reach out to Lucas and I. We could probably spend a half hour talking with you and then figuring out if we know partners that do this. But SUSE is that open platform for you, right? So we'll provide everything up to that machine learning model. We'll provide the framework for retraining the model on new data. And basically, if you find a partner that instead of doing it on your own, we would get that partner certified on SUSE. And that means in the back end, we make sure they have access to the SUSE software and that they build their application to run on top of our K2 and our Kubernetes. And for at least from our side, everything can be air gapped. So being vendor neutral means that we actually have support for, as you saw, the gray areas earlier about stuff we can mix and match. You could even run this on Ubuntu and RHEL, for example. Most customers I work with run on Celeste or SLE Micro, but if you have a requirement for one of those, it's there, and you can even get support from SUSE for the RHEL bits as well, and the CentOS and so on. But yeah, I think Yuri, if you want, reach out to Lucas and I, and we can definitely have a follow up with you. Yeah, you're welcome. Okay. All right, good. Any other questions? We still have, I think, 17 minutes here, Lucas.
Yeah, this is great. Well, I was actually a little bit short on the start. Maybe I will switch to, because there are most of the guys connected here is from Czech Republic. I will talk a little bit in Czech. Okay.
Please do.
Ještě jednou dobrý den, já jsem ten začátek trošku moc utnul. Předal jsem to moc rychle Erikovi. Já se jmenuji Lukáš Laurin, jsem solution architektem pro Českou republiku a snažíme se tady vlastně zvednout povědomí o SUSE jako takovým a vlastně produktech, které SUSE nabízí. Jedním z nich je vlastně SUSE AI. Erik už mluvil o tom, že SUSE AI je vlastně, dá se říct, do velké míry open sourceová platforma. A my se v rámci open source snažíme razit vlastně tu cestu nějakého rušení nějakého vendor lock-inu ať už co se týče hardwareu nebo softwarové platformy a vlastně pomoct tak nějaké digitální suverenitě, což je v poslední době obrovské téma. Určitě jste se s tím setkali i vy. Snažíme se vlastně vám dát do ruky nástroje k tomu, abyste mohli třeba konkrétně v tomhle případě tu AI platformu provozovat lokálně a nespoléhat na nějaké cloudové zdroje, případně AI platformy založené na cloudu, kam vlastně ty data musíte posílat a nemáte nikdy jistotu, co se s nimi děje. Určitě jste si spoustu vás vyzkoušeli nějaké lokální AI řešení, ať už na nějaké supportované enterprise platformě, nebo jenom prostě rozběhnout to někde nějakém Ubantu. A my se vlastně v rámci tohohle snažíme nabídnout alternativu, která běží na certifikovaných řešeních, která běží na certifikovaných řešeních, nad kterými držíme ochranou ruku, co se týče vlastně profesionální podpory a i profesionální pomoci, vám nějakým způsobem pomoci tuto platformu nasadit. A Erik vlastně tady v rámci Evropské unie nebo vlastně EMEA jako regionu je na pozici solution architekta přímo pro AI a je to člověk s velkým technickým zázemím a vlastně i poměrně velkou technickou historií. Takže nejenom, že o tom dokáže mluvit, co se týče prezentace, co bychom s tím mohli udělat, ale je vám schopný to i odprezentovat na funkčním řešení. Jak už ale zmínil, my vlastně poskytujeme tu platformu jako takovou a co se týče konkrétních implementací, tak ty tvoří naši partneři. Čili v okamžiku, kdybyste měli zájem třeba o nasazení lokálního AI u vás, my vám určitě jsme schopni nejenom tu platformu doručit, ale i navázat vás na odpovídajícího partnera, ať už v České republice nebo v rámci Evropské unie a pomoci vám vlastně v nasazení toho lokálního AI řešení, pokud ten tým, který se tomu vede, třeba nemáte. Maybe Eric, if I can ask you if you can share some use cases we already done, maybe from the Kazakhstan, there's quite a big one. Maybe some cases we are currently working on.
Yeah, absolutely. So NITEC being a public reference, I can speak to that one. That is, if you remember the NVIDIA use cases we looked at, right? That is DGX systems, which NVIDIA calls super node. And these systems have 8 GPUs. In this case, there were 8 H100s, I believe, the Hopper series, and running something called RDMA over Converged Ethernet, which is a way of sharing GPU resources across servers for really big use cases. What the customer did at the end of the day is a GPU as a service approach. So the use case was providing public resource access and local company access to GPU resources in the country, and basically doing it with open source, non-vendor lock-in software. So SUSE was a pretty big player in that space, and basically at the end of the day, the NVIDIA hardware was installed. NVIDIA, we installed SUSE virtualization on top, and on top of the SUSE virtualization, we're running multiple Kubernetes clusters, and they're doing PCI pass-through of these GPUs. That's the technology use case. The actual business use case is GPU as a service. So we're starting to look at that. They're already using VLLM and Ray, which are technologies for doing distributed model serving. So think of having an LLM that's going to serve thousands to tens of thousands of users concurrently. That's where this Ray and VLM comes into play. Outside of the use case, that's where we're at. We're starting to do the AI observability there, which is where they want to start tracking, what's being done inside the models. Can they see what was being asked and answered? Quality assurance on those models, and actually doing quantity assessment, like who's the biggest users on the platform, which is what the AI observability provides. On the smaller side, I have partners who are doing 1 to 4 servers. And in there, they're trying to provide a SaaS offering. For them, they want to be able to provide different data scientist use cases. So they're trying to sell to um, the small startups and the mom and pop shops that are trying to do AI, but actually have like college grads who know how to do this and are doing it with their laptops, but they want to move them on to a managed offering. Um, what I see is that companies who are trying AI out for the first time, they'll go and use public cloud because it's cheaper. But when they actually want to do it with the company's data, that data is typically not allowed to be on the public cloud. And with all the geopolitical stuff happening right now, there's a lot more, let's say, nervous executives in Europe seeing that they may lose access to the data or the data may be used in the wrong way. So there's a big interest in sovereignty. So I didn't talk about that today, but I think sovereignty is a something that everyone has a different opinion of what it means. But if I can boil it down, it really means having full control of your data and having full control of your infrastructure and how you life cycle it and not having the least amount of risk to a disruption to your operations of your business. Um, for SUSE, we are a German company. Even though we're based out of Luxembourg, our parent company is Swedish, EQT. And that plays really well within this European market, being that we basically have our entire leadership and everything else out of Europe. Um, Now, that being said, I think the use case question you have, Lucas, it's going to come down to two high level approaches, right? Some of my customers are doing machine learning, so this OCR question is spot on for machine learning. It's doing some task and doing it over and over again. Some customers are doing Gen AI, which means like the digital assistant. You do this inference and you get back. If I ask a question to one of those models, I'm going to get a different answer every time I ask. It's generative. It's on the fly. It may be incorrect. Whereas machine learning, you always want it to be perfectly getting as close to 100% recognition or process that it's going to do over and over. Um, for example, facial recognition, right? That's another repetitive machine learning approach. So if you can classify those two, they're usually one or the other. Sometimes I've seen customers do both, but they're usually pretty advanced. It's been in the medical industry and in the automotive industry. Um, but usually you classify as one or the other. Once you get to there, you then have a business case that's defining, okay, am I going to go, which GPUs do I need? Because some GPUs are better for Gen AI and some are better for machine learning. And actually, the machine learning ones are cheaper. You can go with Ryzen cards or even the RTX series from NVIDIA because you don't need the huge amount of VRAM. And what you need to do easily fits in those cards. So it's a lower cost entry to the investment. Um, I would say that if a company doesn't have a use case and they're looking for one, it's a huge risk to not get a business case. So my recommendation is if you're trying to learn AI, play on the public cloud, maybe do what I did and turn your gaming system into a work system when you're not using it for gaming. But if you're a company, you're probably going to be better off trying a reserved resource on some public cloud just to play around and get used to it. If you're going to build a team out, or if you have a team, do a single node or build an environment the team can share to evaluate the tools. Because I wouldn't recommend jumping into one of these tools and thinking that's going to solve the problem. Make sure your data scientist team is comfortable with that approach. They may have their own opinions. Most likely they do. If you're a large customer or a large partner and you're working with large customers, I would recommend immediately evaluating the frameworks, Kubeflow, MLflow, and maybe the partners like ClearML and others, and figuring out a way to do that. Because if you don't have the framework from day one in mind, you're going to have to go back and reinvent everything later once you start pulling all those disparate teams into one approach. And getting them onto one approach early is probably going to cost less. Um, but outside of that, these use cases, as long as you have a platform that can run the AI workloads, either VM with a GPU or Kubernetes with a GPU, you have the baseline for doing every use case. So you're pretty safe in that aspect.
Absolutely. Well, I wanted to mention that basically every project SUSE have or every service is slightly introduced with AI features. like Rancher. Lately, there's an AI assistant which is able to
Yeah.
communicate with our local AI. Uh, multi-Linux manager is introduced to AI as well. So basically, every AI stuff you want to run can run against the local AI. So even in information about your local infrastructure, which Rancher doesn't have to leave your firewall. So basically, you could solve everything in house.
Yeah.
Maybe a little bit of mention of guardrails if you can. So there's a technology we can use on the AI as well.
Yeah, and Lucas, maybe you can put your email in the chat so that the folks can reach out to you, and then you and I together can follow up on any other questions. We have resources, do proof of concepts with you all. Um, and if you have any kind of, just things you want to know and how SUSE can help in that space, Lucas and I are here to help. And of course, I'll overlay. So I'm backing up Lucas on everything in his region. Um, and to Lucas' questions about guardrails. So I have two questions I typically get from customers. Do we have guardrails? If I'm building a model, how can I make sure that it's actually performing as well or better than the previous iterations of that model? Perfect. And if you reach out to me, I'll pull Lucas in if he's not there. And like I said, I have an architect I work with, so we can help do remote proof of concepts, and we can even do recommendations if you guys are thinking of, building that business case or the RFX that you want to send out to partners and vendors. We can help you with, formulating specific questions or getting things built the right way.
Yeah,
But to that,
if
yeah,
you don't mind, I will jump in really quickly because we will follow up via email. So everybody who
good.
actually joined in will get all the necessary contacts and resources like web pages or the presentation and stuff like that. Okay.
Thanks, Martina. Yeah, good, great. So for guardrails and the others, it's really going to come down to guardrails does inference firewalling. So if Luca and I are talking to a model, like I showed you the digital assistant, guardrails would be sitting in the API path. And if I said, what's Lucas's credit card number? And maybe it has it and it gives it to me. And then I say, well, what's his PIN number for this credit card? Right? That kind of data, me asking the model basically can use guardrails to filter that either via regex or other methods, depending on the type of guardrail tooling used. Um, that's good for user firewalling of a model. And a lot of the time, the neural networks in the model are already blocking this kind of thing. So, for example, if I go and ask 5.4, how do I make meth like in Breaking Bad? It's going to say, sorry, I can't help you with that. But by the way, here's this drug rehabilitation number you can call. Now, if I download the Dolphin version of those kind of models, I'll actually get an answer of what's the chemical formula for it and how to bake meth. So a lot of the models are actually filtered. The Dolphin ones are perfectly built for research purposes to see what's actually in the models. But then that's just between the user and the models. If you actually are a builder of the model, you have this concept of quality assurance of the model. And that's the other aspect of it that I get asked a lot is how do I validate that the models are performing at par or better? And right now, today, there are a few proprietary partners on our side that do this. But at the end of the day, it turns into two things. You typically have a standard QE set of questions you put across the model, or if it's going to be machine learning, a set of photos or a set of audio or whatever the model's built for to run through the model to make sure it gets positive results for those. And then you have a user in there doing a handoff, like a soft handoff in the model where it actually just plugs random things in and sees if it's performing as expected. I'm hoping in the industry we get a better result later, but really what we're going to see probably is that there'll be an LLM for quality assurance, and that LLM will be the one throwing questions at the other model. So it's kind of like battle of the models to see if it's performing well. But the problem is you need to make sure that that one is trained on very specific data about whatever that model is supposed to be good at. But
Yeah.
so I think we're 2 minutes to the top of the hour. Do you want to wrap up or Martina maybe? I'm not sure.
Okay. Okay. I will do one. Uh, if you are interested, as Eric said, you are free to contact us by the email. If you have any questions and you didn't ask in the chat, just send it to us, and we will try to reply as soon as possible. If you want to present our solutions directly to maybe targeted on specific aspects, you are free to ask us as well. We will love to show you more from SUSE AI. I think there are a lot of technologies we can show you from the SUSE SUSE portfolio and help you to maintain digital sovereignty, which is a big theme lately with all the changes through the world. So I guess I will thank you. You did attended this workshop. I'm very sorry for connection issues, but this can happen. We all know that, and I will love to hear from you from with any questions you will have. Thanks a lot. Thanks a lot, Eric, for the presentation. It was great, and have a nice day for everyone. Goodbye.
Okay. Bye, everybody. Thank you.
Hey, everybody.